Hey, what's up, memers? We are going to learn about the domain of rational functions today. We kind of touched on it in the last video, which, by the way, has this sweet new synchronized, how you snized visuals plus audio. How exciting is this? I write stuff as it happens now. How tight is that? Anyway, you're going to learn about the domain of rational functions today. So what that means is you're going to just learn how to figure out what the domain is, and we're going to go over how to rewrite that again. So if you don't remember domain from the last domain video, don't trip about it. I'll teach you again. All right, as normal, we've got to check that vocabulary first, because I'm going to say a bunch of words that you probably have a vague idea about, but you know, it's like that meme where it's like, I don't know what domain is, and at this point I'm too afraid to ask. So I'll just tell you. You don't have to ask. I can read your mind. I know what you're thinking. So the domain is all the x values that work when they're plugged in. And you're going to say, Mr. Barton, work doesn't sound like a math word. You're right. It's a physics word. But what this means to you math people is it don't make, i.e., oh, come on, proofread your stuff. They don't make the function undefined. So when you plug in an x value, if it makes the function undefined, you say, get that out of here. I don't want that in my domain. I don't ever want to see you or your x value around here again, right? Undefined, for those who forgot from one video ago, that just means when the denominator of a fraction equals 0, so no dividing by 0. In math, there's two rules that you know. It's don't take the square root of a negative, but then we learned how to turn this into an I, but you know, c'est la vie anyway. And don't divide by 0. This one is like a real rule that's never, ever, ever going to change. This one, you just had to learn imaginary numbers, so I mean, no big deal there, right? All right. The last thing I'm going to say over and over and over is rational function. And that just means a fraction with a polynomial on the bottom. Good? Okay. Now that you've read all that, or at least had it read to you, maybe copied down even. I might even write it down so that in the next video, you don't have to copy it down a third time. You know? Let's look at an example of finding the domain. Let's pause there, though. Before we talk about the domain, long time ago, in a math class far, far away, Mr. Barton said polynomials, I'm not going to write this, polynomials always have a domain of negative infinity to infinity, right? They go left forever and they go right forever. Rational functions are made of polynomials, but they don't have the same domain. Haha, you guys thought. It's not that easy. So what's nice, though, is because they're made of polynomials, we start with this domain, and then we're just going to take out the pieces we don't want. Okay? So right now, you're thinking, here's my domain. Here, we'll even put it on a number line, right? Here's negative infinity. Here's infinity. There's 0. And then your domain is this blue line. It's a solid blue line. It goes left forever and right forever as of right now. We'll fix this thing as we learn more about domain. So our domain is all the x values that work when they're plugged in, i.e. they don't make the function undefined. So if we want to figure out what the domain is, we need to go figure out where is the function undefined and then take those pieces out. So what we're going to do is we're going to figure out where does this thing have a denominator that equals 0. And the way you do that is you just set these binomials equal to 0 individually, like we've been doing. And you solve for x. And hopefully this isn't too scary, right? You just subtract 4 on both sides, cancel out the 4s, and now you know x equals negative 4. Add 3 on both sides, and x equals 3. You're going to say, Mr. Barton, I thought these were the restrictions. You're right. Those are the restrictions, kids. I'm so glad that you paid attention to that last video. Writing and talking at the same time is hard. Our restrictions are x does not equal negative 4, and x does not equal 3. And maybe not does not equal. Maybe I should be saying can't equal. It's not allowed to. It's not that it just happens to not. It's that it's not allowed to. If you do that, you're breaking this rule and you're going to math heck, where they make you reduce fractions and compute stuff for the rest of eternity, right? It's going to be terrible. All right, so we have our restrictions. So let's go take these out of our domain. So here would be -4. So where this -4 is, on our domain, we just take that thing out. We put an empty, actually let me get an eraser. There we go. Put a hole there. Now our domain looks like that. It's got a hole where -4 is. It still goes left that way forever. All these numbers are still good. Still goes over here. Oh, there's 3. Let's put another hole here. That's 4, so maybe 3 is right there. Put a hole. Put an open circle. This is our new domain. It's everything from -infinity up to -4. Hop over that. Skip it. You're not allowed to use that number. This whole little section in the middle between -4 and 3. But we hop over 3, and then you can just keep going forever. All right? Look, this is like a cute little face. Look at that. Hello, guy. Yeah, right? I accidentally draw robot faces a lot in this class. How weird. All right, so we need to write this domain down. Okay, so let's do this one chunk at a time, and let me move some of this math out of the way. Let me get rid of this robot head too. This thing looks goofy. We don't need this. Delete. Okay. So the way we're going to write this domain, we always want to work from left to right. So it starts, well, it's got an arrow there. So our domain for this function is going to start at -infinity. And remember, infinities always get parentheses because you can't ever get to infinity. And then it keeps going all the way up to here at -4. So we're going to put that to -4. Now I'm going to ask you a dumb question. Are we including -4? No, Mr. Barton, there's an open circle. Look, it's a restriction, you dummy. No, we're not including. How dare you ask? Thanks, kids. You don't have to be mean about it. So because we're not including the 4, because there's an open circle here, because it's a restricted value, we can't use it, so we don't include it. So it gets a parenthesis, not a bracket. All right. Now we need to say this little chunk here. That chunk, sorry, let me just rearrange this a little bit. Sorry, my own writing's getting in the way. Okay. This chunk goes from -4 to +3, and we're not including those. You're going to remember from like your kindergarten math class, when we want to connect two intervals, we have to do it with a union. So we have this thing and this thing, and now we have one more section here. So we need another union. I'm going to write down here because I'm out of space. This section goes from 3, but not including because it's an open circle. And that just goes right till we hit an arrow. So to +infinity. So this is the domain of this function. And you're done. You did it. You got the whole domain. A couple things I'd like to point out to you. This goes -4, and then the next interval starts with -4. This interval ends with 3, and the next one starts with 3. That should pretty much always happen for rational functions. I can't think of, in the 1.5 seconds I thought about it, think of a function where that won't happen. But in math, I'm very cautious to say always and never. Only a Sith deals in absolutes. All right, let's go look at another example so that maybe we can quit making prequel jokes. All right, so here, again, we don't really care what the roots are. So the top, not important. Don't even look at the top. We're not asking about the top. We're asking about the domain, and the only thing that affects the domain is the bottom. So we're going to set the bottom equal to 0, and we're going to solve for our restrictions. I'll even write it up here. Restrictions. Okay. So set this equal to 0. 3x plus 4 equals 0. Oh no, Mr. Barton, I can't just move the 4. I have to do 2 steps now. Oh no, I have to divide Oh no, look, it doesn't even simplify, Mr. Barton. Oh no, x does not equal negative 4 over 3. Okay, just write it down. Quit tripping out, kid. It's just a fraction. Like, it's not disappointing your parents. You don't need to be afraid of it. All right, now we do the same thing with this. X plus 9 equals 0. Subtract 9 on both sides. X don't equal negative 9. Don't tell your English teachers I said that. All right, here are our restrictions. So one more time, just to make this really nice and visual for you. Is it okay if I erase all this algebra? All I did was set these equal to 0 and solve for x. Yes, Mr. Barton, you can erase it. We don't need that anymore. Okay, thanks, kids. So one more time, so this is nice and visual for you. Normal polynomials have a domain that goes left forever and right forever. So we're going to start with that. That's our regular domain. Now we need to put holes where the restrictions are. So here at negative 4 over 3, this is negative 1 and 1/3. So a little bit past negative 1. So we go negative 1. Whoops, that's a really big hole. Undo. There we go. Put a little tiny hole and put an open circle to show that there's a hole there. This is negative 4 over 3. And then we go over to 9, not to scale, obviously. We put a little tiny hole in there, and then we put an open circle to show that there's a hole. Now we need to write this blue line in domain, or rather, excuse me, I misspoke, interval notation. We need to write our domain, which is this blue line, in interval notation. So the domain for this function is going to be from negative infinity, because we always start on the left with our arrow, negative infinity to this first hole, which is at negative 4 over 3. Parenthesis, because we're not including the point, it's a restriction, you're not allowed to use it. Union to connect the next little chunk. So this chunk here goes from wherever we ended the last chunk, so negative 4 over 3, to here, which is at 9. Parenthesis, again, because we're not including it. It's a restriction. Union to connect our last little piece here. It starts at 9 and goes to an arrow, so to positive infinity. And then this is the domain of your function. That end, easy. All right, we're gonna do one more just to put hair on your butts. You know, you might wanna pause the video now, stand up, kiss your family goodbye, go put on your big boy chonies, and get ready for a hard example. Example number 3. Oh my God, oh goodness, excuse me. Oh my goodness, I took the Lord's name in vain. Don't tell your mom. What is this, Mr. Barton? It doesn't matter what this is. It's in the top. Just get rid of that. But for real, Mr. Barton, what is that? That's an integral, kids. You're going to learn about this thing in calculus. This thing is rad as heck. But for right now, it doesn't matter. Okay. So the bottom. Oh no, Mr. Barton, how do I set this equal to 0? We have to factor this. Oh no, Mr. Barton, you know my 3 greatest fears are being buried alive, being burned to death in a volcano, and factoring. I know. So I'm here. This is an example. I'm going to do the hard work. You just sit back and copy everything down. Because we have a number in front of our x squared, we're going to do complex factoring. And I know it'll complex factor because I wrote the problem and it's going to factor nice. So to complex factor, first we throw that 10 to the back and we multiply it to the negative 4. So we have x squared minus 3x minus 40. Now we simple factor this thing. So we need 2 numbers that multiply to negative 40 and add up to negative 3. So that's going to be x minus 8, x plus 5. And let's just double check. Negative 8 times 5 is negative 40. Yup. Negative 8 plus 5 is negative 3. Yup. Okay, cool. Perfect. It's mostly factored, but this is kind of an illegal step. We're avoiding completing the square because I don't like it. Now we have to divide by that 10 to make it okay. All right, reduce our fractions. So 8 over 10 turns into 4 over 5. and then we take the denominator and turn it into a coefficient of x. So this part turns into 5x minus 4. And then 5 over 10 reduces to 1 over 2. Throw the denominator in front. 2x plus 1. All right. Now, this thing is all factored, and we can set these equal to 0 to solve for our restrictions. So we have 5x minus 4 equals 0. We add the 4 on both sides. 5x equals 4. Divide by 5. Bob's your uncle. X equals 4 over 5. So that's one of our restrictions. X cannot equal whatever I just said, 4 over 5. All right, let's do the other binomial. 2x plus 1 equals 0. Subtract 1. 2x equals negative 1. Divide by 2. X equals negative 1/2. Maria Zartia. X does not equal negative 1/2. All right, now that we have our restrictions, we're ready to go write our domain. So let's make this a little visual again for you guys. Oh, hold on. I'm really disappointed with that straight line. Let's try that one more time. Much straighter. There we go. All right, so normal polynomials go from negative infinity to infinity. There's 0 right in the middle. We need to put holes in our domain at those two spots. So negative 1/2, we'll go left a half. Sure, that's a half. And then we will put the hole. This is negative 1/2. And then positive 4/5, that's almost 1. So let's see, that's a half, almost 1. Right there. Wonderful. There's our other hole in our domain at 4/5. If you guys hear any noise, that's just my wife and dogs being super disrespectful and eating while I'm making videos. Don't mind them. So now our domain starts at negative infinity and goes to the first hole at negative 1/2. Union, now we need this middle chunk. It goes from negative 1/2 to 4/5. Union, now we need this last chunk that goes from 4/5 right forever, so we put infinity. And there's your domain. Hopefully that's not too bad. We're just adding one more step onto finding those restrictions from the last video, which is putting it in interval notation and writing it like we know what we're talking about. If you need help, of course I'm here to support you day and evening until 3:30. If you need help, ask me in the WebEx, send me a message on Band, email me. If you are some poor kid in South Ireland trying to learn math and your Irish teacher doesn't teach you good, I don't know what to tell you, dude. Like, good luck being whatever kids who don't know math in Ireland grow up to be. All right, I'll see you guys in the next video.